Hello friends, I am Enkejan from Skill on Tech. Today I will explain you about cooling towers, how it works. I will introduce you a induced draft FRP Pultruted cooling tower which is counterflow. Cooling tower is an important unit of any process plant where heat of process is ejected and cooling water is supplied to the process from cooling tower. So how that water is cooled in the cooling tower? What are the important components of a cooling tower will be explained in this video. The video belongs to Aquan group of companies of Russia. They are famous in construction of cooling towers and water recycling systems. So in this video, you can see a picture where a Pultruted FRP induced draft cooling tower is shown. In this picture, you can see there are two cells of cooling tower, cell 1 and cell 2. The capacity of cooling tower is based on return header flow passing through a cooling tower. It can be 400 meter cube per hour or it can be a 4000 meter cube per hour. That depends upon the size of the cooling tower, and number of cells also based upon the cooling water flow. So let us see. You can see in this picture, this is a return header which is coming from a process plant, and these are the branches. In the bottom you can see a cold water basin. Here you can see in this picture there are two fans inside of these fan cylinders. These are the fan cylinders and they are FRP fans. Now we can see how water is recycled in a process plant. You can see a pump house and a production plant, process plant where production takes place, and a cooling tower. So water is recycled from a process plant to cooling tower, and then cooling tower to pump house, and pump house pumped this cold water to process plant or production plant where cold water is supplied to heat exchangers and heat transfer takes place for maintaining temperature of process plant. So you can see in this picture, by this we can save 25 to 50 times of natural water resources by providing a cooling tower. Cooling towers are generally, you can see in chemical plants, fertilizer plants, refineries and other plants also where this heat rejection process is required. The evaporation losses from a cooling tower is not more than 5%. So now you can see the cooling water is recirculated and hot water is supplied back to cooling tower from a production unit. The evaporation from a cooling tower is made up by a supply of a raw water to the cooling tower. Now you can see in this picture, this is a FRP Pultruted induced draft cooling tower, and we will see its all entire components and the different aspects of components. The cooling of water in the cooling tower take place in the PVC fills area where heat is exchanged to air and air is thrown out from fan to atmosphere. So evaporation of water take place at PVC cooling fields. You can see in this picture, this is a PVC fill section where PVC fills are provided, and this is a distribution header which is connected to return header, and in this distribution header nozzles are provided for spraying water over the PVC fills. The entire cooling tower is erected on FRP columns. FRP is basically a fiber glass reinforced plastic. This is a latest development in the technology of construction of cooling towers, because FRP cooling towers have various advantages over wooden and concrete cooling towers. They are corrosion resistant, temperature resistant, and algae also not deposited much over FRP. FRP is in lightweight, therefore cost of construction of cooling tower is also very less. Here you can see these are the PVC fills. So these PVC fills are constructed in molded and corrugated for increasing the surface area of the heat exchange area. The thickness of sheet of PVC fills is generally 0.2 to 0.3 mm. So in this area, water is completely spread over the PVC fills first, and then after distribution of complete water, induced draft fan is started for flowing air through the PVC fills area. Now you can see here this is a fan and here this is a gearbox. The fan blades are generally FRP or aluminum, but FRP blades are preferred because they are in lightweight and they can save electric power. So generally hollow and molded FRP fan blades are preferred in construction of cooling towers. Here you can see the hot water from a process plant is coming from this return header. Now you can see the hot water is going through a distribution header, and then from a distribution nozzle it is sprayed over the PVC fills and then fall into the cold basin. So this system goes continuously on. Here you can see these are the PVC fills which are shown, and they are available in different colors. And these PVC fills area is increased by making these PVC fills in corrugated sections. The PVC fills are prepared at site where cooling tower construction is going on. These are made in sections, and the sections of PVC fills are fixed in the cooling tower over FRP structural supports. Now you can see the hot water is continuously coming from the process plant and spraying through nozzles over the PVC films. When the complete PVC fills are wet, the fan is started. Once fan is started, the air from atmosphere is sucked from the bottom portion of the cooling tower through louvers, and from bottom it goes on upward and sucked by induced draft fan. The air going across the PVC films and get exchange heat from water to air. In this process, water gets evaporated and cooling effect of water occur, and the cold water fall into the cold water basin through gravity, and the hot air is carried away by fan to the atmosphere. You can see in this process some water vapors are also carried over by air, which can be seen here. So you can see a cloud of water vapors over the top of the fan cylinder. Now you can see the air is continuously coming and going upward through fan, and heat is getting exchanged at PVC fills. In this picture you can see this is a gearbox and this is a driving shaft, and this shaft is connecting gearbox to driving motor. The motors are generally 3-phase induction motors, or they can be variable frequency drives to serve purpose of electricity saving as per the load of the cooling tower. So here you can see the fans are rotating, which is mounted on the top of the gear shaft, and this shaft is rotating this gearbox, and gearbox are reduction gearbox. So they are defined by the model of gearbox which is used in the cooling tower. So here you can see the air is coming from bottom going out and continuously it is getting exchanged. The cooling limit of water cooling towers depends upon approach. Approach is a difference between wet bulb temperature and cooling water temperature. The cold basin cold water temperature and wet bulb temperature will give you approach of the cooling tower, and by that we can know the effectiveness of the cooling tower. One important term is range in the cooling towers, that is a difference between return header hot water temperature and cold water temperature. I will describe how to evaluate effectiveness of a cooling tower in my next video. The evaluation of cooling tower effectiveness is generally based on temperature difference of wet bulb and cooling tower cold water temperatures. Approach generally should be within the range of 3.5 to 4 degrees centigrade. If your approach of a cooling tower is more than 4 degrees centigrade, then we can say cooling tower is not effectively working. The droplets of water which is sprayed from a nozzles over the PVC fills are in the range of 100 to 500 microns. Now you can see here, these are the drift eliminators. When these water vapors are carried over by air towards the fan, so these drift eliminators will prevent the water vapors and sent back to them over the PVC films. and we can have a minimum drift losses. So drift eliminators are also be very important component of a cooling tower, and they should also be inspected time to time for any damages. The PVC fills are also damaged over a period of time, and they shall also be annually inspected, and after choking of fills, they shall be replaced. The period of choking may be 2 to 3 years. So this based upon the environment of the industry. So as per the requirement, PVC fills are also to be replaced with the new PVC fills whenever required to improve the effectiveness of cooling tower. So this will increase the efficiency of cooling tower. One more important thing which is to be taken care is a gearbox. The oil of gearbox shall be maintained properly and it is to be top up time to time. The vibration of rotating components should not be more than 4 mm per second for a excellent performance of rotating components. If vibrations are increasing, then we have to inspect the alignment of motor and gearbox as well as looseness of structures and other components of cooling tower. So now you can see the cold water is continuously falling in the cold basin and then it will be pumped to process plant. This is all about cooling tower and its component functioning. I hope you understand how cooling tower is important for any industrial plants. Thanks for watching the video. If you like this video, hit like button below, share it with your friends and colleagues, subscribe our channel for getting updates on upcoming videos. Please leave any comments, feedback to improve the videos. Thank you.